Hey everybody, it's your Chem SI Sarah coming at you with some Chem tips and walkthroughs for worksheets like this one. Valence, bond theory, and shape interactions. So let's get started. So the first set of directions is using an AXE type of model. And see, the A is the central atom, X is the ligands that we know is just atoms connected to another atom, mainly central atom, and E is lone pairs. So, if you're looking here, we know Lewis dot structures, I pray. But when we set them all up, it's 6 of these bromines attached to the sulfur. And the A is usually just A. It's usually just 1. X is 6 in this case because there are 6 electron groups. 1, 2, 3, 4, 5, 6. And then there's no lone pair, so it's 0. Then for this guy, it's HBEH. And there's just 2 electron groups, 0 lone pairs, 1A. And then for this guy, it is 3, as you can see, and 1 lone pair. So it'd be 3 for the X and 1 for the E. Alright. Going down a bit. So we're supposed to write the hybridization of the central atom and see how it has the given stuff: sp, sp2, sp3, sp3d, and sp3d2. It just depends on how far you're going in the hybridizations. So like, trigonal bipyramidals and octahedrals and all that. So for this one, it's just linear. It's just 2. It's just sp. This guy, it is 4 tetrahedral. So it's sp3. And this one is 1, 2, 3, 4, 5. So that's trigonal bipyramidal, sp3d. Then this one is 6. If you can see how there's 1, 2, 3, 4 bonds and then 2 lone pairs. Add it up all together, you get 6. That's octahedral, so it's sp3d2. Okay, so then for sigma and pi bonds. So the bond sets up how many types of sigma or pi bonds you're getting. So for a single, it's usually 1. For the double, it's 1 sigma and 1 pi. And triple, it's 1 sigma and 2 pi's. And the pi bonds are like, they look usually like this. See, like it's like this. So it's forming like that pi symbol that you know of. So that is why it is the way it is. And that is a pi bond. Sigma bonds are just like that. Like just sigma. They're cool too, but the more bond lengths you get, the more bonds you get, the more you'll get of pi rather than just sigma. So in this case, we're looking at C, this carbon, and this big compound of sorts. And so you can see that this is just a triple bond, which is 1 sigma, 2 pi. And then that's a single bond, so that's 1 sigma. So number of sigma bonds is 2, pi bonds is 2. And because it's just 2 of them, 2 electron groups, it's linear, so it's just sp for its orbital hybridization. Okay, last one. So now we're using a condensed structure and we're trying to fill in the blanks. So here's our condensed structure. Now it says revert to normal structure because that helps. So when we revert it, we get something like this. See how there's the H, and N, the C, the H2s, the carbonyl group, that's a methyl group, that's an amino group. This is a hydroxide group. Fun stuff. Make sure you memorize your types of groups for these when you're writing out Lewis structures. Very much helps, and very much helps when you're doing condensed structures. So in this case, when we write it out normal, we see a lot of lone pairs. We see the H and the N's and the CC's. So let's just go down the list. C bonds, it's just 1. CH bonds, 1, 2. So 2. OH bonds, 1. And NH bonds, 1, 2. So 2. And then lone pairs, we got 1, 2, 3, 4, and 5. So that is 5 lone pairs. So that is how you do this worksheet on the different types of, shape interactions and valence bond theories. If you have any questions, please do so in the discussion tab on Canvas, and maybe comment down below if you have any questions in the video. Alright then, see ya.